Good evening, Internet. Matt Booyak here, and tonight I'm going to be solving the fourth problem on the Project Euler problem archive. So for this problem, we just need to find the largest palindrome, which is a product of two 3-digit numbers. So just to start off, we can get an idea for the range of numbers that we're talking about here. At the low end, we have 100 times 100 is going to be 10,000, and at the low end, or excuse me, at the high end, we'll have 999 times 999, just less than 1 million. But it's highly likely, just based on the number of 6-digit numbers and the number of 5-digit numbers, that our answer is going to be 6 digits. And that simplifies the logic slightly, so we're just going to assume that our answer is 6 digits. And if we find that that's not the case, that there are no palindromes, 6-digit palindromes, which are a product of two 3-digit numbers, then we can revise our approach. But for now, we'll assume that it's 6 digits. So I think the key observation, or really there's two key observations in approaching this problem. And the first is that there are far more products of 3-digit numbers than there are palindromes. There are, in fact, 900 6-digit palindromes. And the way we know that is if you take a 3-digit number and you just reflect it over itself, then you'll get a 6-digit palindrome. And so as opposed to the number of products of two 3-digit numbers, which is much larger. And so rather than starting with products of 3-digit numbers and trying to find one that is a palindrome, we're going to take the opposite approach of starting with numbers that we know are palindromes and trying to find one that's divisible by, or that's the product of two 3-digit numbers. So the approach we're going to take to finding the largest such palindrome is pretty straightforward. We're just going to start with a 3-digit number, in particular 999, and count down from 999. And for each 3-digit number, we're going to make the corresponding palindrome by reflecting that 3-digit number over that center line to create a 6-digit palindromic number. And then we just need to determine the first such number that's divisible by a 3-digit number, resulting in another 3-digit number. So let's jump into the code here. Open up Emacs, and we'll open up a shell. Make sure my shell is actually visible to you all. And we will copy our template directory to make problem 4. And open our main.cpp. So the key bit of code in this solution here is gonna be the code that takes a 3-digit number and gives us back the corresponding 6-digit palindrome. And so we're going to take that code and separate that out into a function. So far, we've been doing all of our work for all the other solutions in just the main function. But often, especially with larger coding projects, you need a better way of organizing your code. And one of the most basic ways of doing this is just to have a separate function that does a specific task. So we're going to say, let's see, uint 32t, and we'll just call it make palindrome. And that's going to take another uint 32t, call it x. Actually, we'll call it lowercase n. I think that'll be fine. Okay, so let's write this code so that we don't assume that this is a 3-digit number here. One thing that will let us do is in the problem statement here, they give us this example of the largest palindrome that's the product of two-digit numbers. And if we make our code so that it doesn't care how many digits this number is, then we can try that example input and make sure that our code is working as expected. So the first thing we can do is let's convert this to a string. So there's a function. Let's see here. Actually, yeah. So there's a function sprintf, which lets you essentially it takes arguments of different kinds, integers, strings, characters, and it puts them together in a format that you specify. And in this case, we're just going to be using that to create a string out of our integer here. So we need a character buffer, and a 32-bit integer is going to be, at most it's going to be like 4 billion here. So that's going to be 10 digits. One thing to be aware of with C and C++ is that a string takes up 1 extra byte because there's a 0 that just after the end of the string to indicate that that's where the end of the string is. And so we only need 10 characters, but our buffer here is going to need to be 11. Again, this is in our case, when this is a 2 or 3-digit number, we know we don't need a buffer this large, but just to make our code as general as possible, this could be up to 10 digits, and so having an 11-character buffer will always be sufficient there. Okay, so let's do sprintf, and actually let's check real quick. Okay, so we already have standard I/O, and so we don't need to include any additional headers. I wasn't certain whether we would have to include string.h or not, but it turns out we don't. And so here we'll just say %u, and we're going to take the argument of n, and our target buffer is buffer. And so this is going to take. So this is indicating the target buffer here, which is just our buffer there. This argument is indicating the format that our output is going to take. And in this case, we're saying we just have a single unsigned integer is our output, and then this is that unsigned integer. Okay, so let's so now that we've turned this into a string, let's check how long that is, and we'll just say size t len, and say len equals strlen buffer. So this strlen is just a function that that checks to see what the length of the string is. And notice that this is not the length of the buffer. This is the length of the actual string, so how big this number actually is. So that is whether it's a 2-digit number or a 3-digit number, etc. And so then, actually, making a quick design decision here. So even though our input can only be up to 10 characters, obviously when we make the palindrome, it's going to need to be more than that. But then the question is, if we put in a particularly large, uint32t, the result is not going to fit in a uint32t. And so I think, in this case, we do like our code to be general, but I think it's okay if we just limit this to uint32t and accept that that this input here is going to have to be less than what is that, 2 to the 15th, or sorry, 2 to the 15th or 16th. Okay, so so now that we know the length of our number here, we need to shift it up to make room for the lower half of the palindrome. So we'll just get a number there, and we'll say for I is 0 and I is less than length. So here's another point of caution. If we do this sort of naively and we start by moving it from the lowest, from the ones place, then we're gonna possibly trip over ourselves here. Actually, no, we'll be fine. We'll be fine because we're moving it by the full length of the string, so we'll be okay. So then we'll say buffer len plus I is equal to yeah, I believe that's correct. Okay, so you have to be a bit careful. In C and C++, your buffer is going to be 0 indexed, which means if you want the first element in your buffer is going to be that, and so the last element in your buffer is not going to be say, you know, buffer len. It's actually going to be buffer len minus 1 is going to be the last element. And then, so if we're reflecting this across that center point, then and I've realized I've actually made a small mistake here. We actually do still need to shift. We need to both shift and reflect our string. So let's do 2 times len minus 1. No. Buffer len plus I equals buffer I. And then we have our reflection code. And we'll say buffer len minus I is equal to okay. All right. Sorry for the confusion there. Yeah, I believe this is what we want to do. We want to shift our because we do want if we're starting with 999, we want the first 3 characters in our 6-digit number to be 999. And if for example, after we decrement several times, we end up with 991, if we were to reflect that, you'd end up with 199 as our first digits. And we want to be careful that we're examining the palindromes in order of in descending order. And so reflecting it and then, or shifting it and then reflecting it is I think what we want here. And oh, this is also wrong. Okay, so now that we have our final palindrome as a string, we need to convert it back into an integer. And there's another function we can use to do that called I to A. If you look here, you can see Oh, I see. It both returns and okay. This prototype here was not exactly what I expected. Okay. So we say a to I. This actually won't. No, that will. Wait a minute here. Oh, I typed in the wrong function there. There we go. That's the one we want. I was confused by why that wasn't matching my my expectations there. Okay, yes, that's more like what I expected. Okay, so one point of caution here is now that we've done this reflection, the last we've actually overwritten that terminating 0 in our buffer. So we want to say buffer 2 times length is going to be equal to 0, and then we'll say return. Okay. So now the main function here should be pretty straightforward. Just get some. Okay, so as I said, we're going to start from 999. And we're going to say while I is greater than or equal to 100. Because if it goes below 100, oh, actually, yes. If I goes below 100, then obviously we don't have a 6-digit palindrome anymore. And then we'll do minus minus I. And then we will, let's see here, we'll say uint32t palindrome. Say palindrome equals make palindrome, and we'll give it our number here. And then we'll say for j equals 100, j is less than 999, less than 1,000. Increment j, and then we'll say if palindrome mod j equals 0, and palindrome divided by j is greater than or equal to 100. Oh, I see. I've added an extra parentheses there. Then we'll say, let's see, palindrome. Actually, no, we'll just say %u equals %u times %u. And then we'll say palindrome j, palindrome divided by j. And then at that point we'll just exit. Now, one problem with the way that I've done this is that we can't easily test our 2-digit case. So let me make a few revisions here. Let's make some constants. We'll call them upper bound and lower bound. This is generally good practice anyway to avoid using hard-coded constants here. So then we'll say upper bound and we'll say oh, this is incorrect. And then we'll say, let's see, j is equal to, that's going to be our lower bound, and then yeah, and then here we've got, it's going to be less than or equal to our upper bound. Again, here this will be lower bound. I believe I've missed an include file here, so let's just check real quick. Okay, we do need string.h. In fact, I did not need it for sprintf, but do need it for strlen. Okay, so it's got, oh, this is very interesting. So apparently we've made a mistake here. Okay, I did not check that. Let's okay, so we both want our factor here to be greater than the lower bound and less than the upper bound. So we'll say factor greater than or equal to the lower bound and factor less than or equal to upper bound. I believe that should be correct. I've made a typo apparently. Still getting the wrong answer. So we are getting palindromes, so that's promising. take a look at our example here. Yeah, it's not obvious to me what we're doing wrong, so we'll have to, I think, pull out the debugger and see what exactly is the mistake here. So I think the most promising approach to this is we're just going to set a breakpoint on this line here. So this is the line 37, so we'll say break main.cpp 37 condition 1, and so we want our palindrome to be 9009. Keep leaving off that E. And we want J to be 91. Okay, so this is interesting. Somehow we're not hitting that case. Okay, so the fact that we're not hitting this line with the conditions I expected, I just want to make sure that we're actually hitting this line with the value of palindrome that we expect. So I've set a breakpoint on that line, and now we're just going to check that palindrome is equal to 9009. Okay, so we're apparently never creating that particular palindrome. So it seems there's something going wrong in our palindrome creation code here. So let's change our condition for, we'll say condition 2, and we'll say I is equal to So I just realized I set my breakpoint in the wrong place, but I believe I think that's still okay. So we'll say I is equal to 90. And run. That's very curious. Okay, so let's put a breakpoint down here where we exit and see what the value of I is at that point. Okay, so so apparently, despite my best efforts, I've somehow got my palindrome flipped around anyway. Somehow 92 is becoming, I believe it was 2992. Okay, so let's change our second breakpoint to be I is equal to 92. And now we're going to step into this function. On one hand, I'm kind of disappointed in myself that I apparently made a mistake some here, but this does give you a little bit of a chance to see what the debugging process looks like, and some of the techniques that I use to track down the problem. I'm sure some of you are looking at this, and I'm sure you see the mistake and you're just like shaking your head, but well, all we can do is keep moving forward. So all right, so we're in our make palindrome here. And let's see, we've got our value of 92. And let's say step. Actually, it's unfortunate. I know some versions of this debugger will actually show you the string. Perhaps like this? No. It's unfortunate we have to do it this way. Okay, so that's oh, of course, I've gotten it backwards in my own mind. The ones digit appears at the end of the string. Yeah, I was thinking of it backwards. Okay, so I think I was actually right when I was originally putting this together, and somehow I got myself confused. Yeah, so we do just need, I believe, this reflection here. Ah, yes, we're reflecting it the other way, and so now instead of reflecting the second half back to the first half, we're doing it the other direction. Yeah. Okay, so after a long detour through my own confusion, we managed to get to the right answer here. Okay, so now we can try solving the actual problem. If we go down here and we just add another character on the end there. Okay, so it's telling us 906609 is equal to 913 times 913. So as a no reason that to believe that basic multiplication has failed us, but I always like to try to do some kind of basic sanity check. So yeah, that does match match the number there. So 906,609, and we'll check the archive here. And that is the expected answer. Took a little bit longer to get there than I expected, but thanks for hanging in there with me. And the next video will cover problem number 5.